Hi, welcome to the channel Too Irrational. I'm Pranay Sharma, and in this video, we are going to see a few types of plots in R programming. This is a part of a series where we are learning basics of R programming using RStudio. And if you have not gone through the previous videos, I would recommend you do so. I'll leave the link down in the description of the complete playlist. You should check it out. Let's get started. The first plot that we are going to study is bar plot. Bar plot, bar diagram, bar chart, it's nothing but the same thing. But the function that we write here is bar plot. Now, bar plot requires a vector of height of each of those bars. Let's say I'm writing a few values here. These are nothing but the height of the bars. So I have 5 bars and I'll just make a bar plot. Function is as simple as bar plot and give the heights. And here you can see a bar plot. You can see 5, 6, 4, 9, and 6. Every plot requires proper labeling. And for bar plot, first of all, we label what these bars are. So let's assume that these are nothing but the sale values of particular years. Let's say I will write names. It should be a vector of strings because these are names. So let's say 2005. I need 5 values. I think I'm done with 5. I'll press Control Enter. And here the argument that I'm going to write is names.arg. Here you can see names.arg. That should be equal to these names that I have written as a vector. And here you can see I have now these values, names of each of these bars. The other type of labeling that we can do is write down what this x-axis values are, y-axis values are, and also the main title. This will be common for any kind of plot that we are going to make in the future. So to write the main title of any plot, we'll write main and in double inverted commas because it's going to be the name. We'll have sales per year. Then if I want to write the x-axis value or x-axis name, it should be xlab or xlabel. And for y-axis value, it would be ylab or ylabel. Here you will see the main title is sales per year. The x-axis title is year and y-axis title is sales in tons. This can be done in any plot. You can also change the color of these bars so that it becomes easier for you to visualize. So for that we have the argument col and you can write red, blue, green, whatever you want to. Control enter and here you get the red color. While showing you all the different types of arguments that we can use in this bar plot, I have actually created 4 plots. You can see here 1, 2, 3, and 4. All these 4 plots are here on this same plot and I can see them using these arrows. If I press arrows, you will see all the previous plots. So this area, plot area, holds all the plots that we have created. Now, if I want to remove a plot, I can click this. This is nothing but remove the current plot. Yes, I don't have that first plot. I can remove the second plot. Yes, I don't have the second plot. I have only this and this plots. Here you can see only 2 plots. If I want to remove the complete plot, I can click this. This is nothing but the broom. And I have no plots now. So I'll run this again to have this plot. And here we go. You can export a plot. You have a sign here export. You can save it as an image, save it as a PDF, or you can copy to clipboard and paste it wherever you want to paste the plot. The second type of plot that we are going to study is histogram. Histogram is used for usually continuous data, but you can always make histogram for a discrete data as well. Let me just create a data from random numbers coming from a normal distribution. I will take 1000 values. So now I have 1000 values, continuous values that I can use for creating a histogram. So to create a histogram, the function is hist, and then we just give the data that we are talking about. And here you can see this is an histogram. Even though histogram looks like a bar plot, it is very much different from a bar plot. It is a representation of frequencies of grouped data. So you can say that I have different groups here for which they have created small bars. And for each group, they have these frequencies. So it seems like R programming has divided this in logical groups of 20. So this 0 to 20, then 20 to 40, and then 40 to 60. That is why 50 is exactly in middle of this bar. If you want, you can change these groups as well. These are called as breaks. If you're planning to change the breaks here, you have to make sure that the smallest and the largest value is included in your breaks. So what I'll do is I'll find the minimum value. Minimum value is minus 94. So if I take minus 100 as my starting point, that will be fine. I will take the maximum value. Maximum value is 136. So if my final break is 140, it will include all the values. So here I will give breaks, comma. These breaks are nothing but a vector of all the values where break should occur. So from the starting till the last value. So the starting value is minus 100. I want it to go till 140, and let's say I want a break of 10. Now if I press Control Enter, here you can see now it's more detailed histogram. Each of these breaks are now of 10 values each. By default, an histogram is going to be a frequency histogram. That means it counted how many values of each are here, and it gave us this frequency histogram. But we can create a probability histogram also, where here it will show us nothing but a density. So if I say probability is equals to true, for true you can use capital T or just write TRUE, everything in capital. I prefer just writing capital T. If I press Control Enter, I get here density, and you will see here now values have changed. The previous one had frequency, and now this is nothing but the probability or probability density rather. You can always change the name of this histogram using the main, change the x-axis and the y-axis label by x-lab and y-lab exactly the same way we did in the bar plot. And of course, you can change the color as well. So just to show you, I will just copy all of these, paste it here, and if I run it, you can see y-axis value, x-axis value, the main title as well as the color, all of these things have changed. Although we prefer not to change the Y label because usually for a histogram, either we have frequency or we have density in the Y-axis label, and that is fine for us. To create a scatter plot, we are going to require two datas. I have now here randomly taken X and Y. These are 10 values of each. If you're following, you can copy this and I'll run them. So now I have two vectors X and Y. If I want to create a scatter plot, the function that we have is very simple. That is plot, and we'll give the two variables X, comma Y. When I press Control Enter, I'll get the scatter plot of this data. So if you see, the first point is going to be X as 65 and Y as 44. So that is what this first point. So this first point is here. This is 65, 44, and so on. Each one of these points is correspondingly plotted here. And that is why we required exactly the same number of values in both X and Y. That was very important. You can modify the scatter plot in many different ways. You can change the size of these points. That is, I guess, CEX. If I change it to 5, you can see the size of the points are very large. You can change it to 2, or by default, I think it was 1. This was the original size. I can even change the type of this plot by changing it into lines. So if I say type is equals to, in inverted commas, we'll write L. If I press Control Enter, all of these points are joined by a line. There are many different combinations that you can show here. To get the complete idea, you can go to Help. We'll type here plot dot default. Here it is. And you will see here we have type. They have talked about all different types. P is for points, L is for lines, B is for both points and lines, C is for empty points joined by lines, O is for overlapping points and lines, small s and capital S is for stair steps, and H for histogram, like vertical lines. So you can try all of these and check what kind of graphs you are getting. If you don't write the type, by default, it will give you points. Here we go. You can always change the name. Main will give you the title, main title, X label, and Y label by X lab, Y lab. You can change the color by COL. It will change the color of these points. Usually in a scatter plot, we are also comparing it to the regression line that we are getting here. Now to make that regression line, first we create a model. So let's say model, I am writing it as LM for linear model, and say Y follows X. Okay, because Y axis value follows X axis value. This is what we want in our model. Next, to plot the line on this scatter plot, we are going to use the function abline. Abline will give model, and let's change the color. I'll say COL is equals to blue. And here you can see this is the regression line created by the same data X and Y. AB line is used to create a line on an existing plot. So there has to be an existing plot before we can write this AB line. I can create a straight line, I can create a dashed line, I can create a point line, I can have a point dash line. For that, we use the argument LTY. To change the line type, we use LTY. And to know different line types, you can again go to help. We are here at our plot.default. Here, if you go down, here you can see LTY. So a vector of line types. You can see it here by clicking. If you go down, you will find LTY. Here it is LTY. It says 1 is solid line, 2 is dashed line, 3 is dotted line, 4 is dot dash, 5th is long dash, 6 is two dashes. These are all different kinds, and 0 is blank. We don't really use 0. So anywhere from 1 to 6 you can use to create different kinds of line. So let's say if I want a dotted line, I will use LTY is equals to 3. But I'll have to use a different plot because there is already this line here. So I will remove this plot, and I will maybe remove all plots. I don't need them. I'll recreate this plot, and now I'll say line type 3. When I press Control Enter, you can see here I get a blue dotted line. So you can try 0 to 6. You have different kinds of line type. If you want to change the width of line, you have LWD. L, that is line width. Line width, again, it's a numerical value. If I say 4, it will create a line with a width 4. Let's say line type is 1, that is solid line. Press Control Enter. You can see the line is now a wider line. So LTY is for line type, LWD is for line width. Anywhere you have a line plot, you can always use these two arguments to change the line type or to change the line width. We can talk more about this AB line function. The AB line function can be used to create line on an existing plot, and it can be used to create any different kinds of line. So first of all, if I want to create a vertical line, say V is equal to, and I'll give, let's say, 55. It will create a vertical line here. So 55, I'll change the color so that we can differentiate them to red. Here you can see that I have a red line, a vertical line. Similarly, if I want a horizontal line here, let's say 90, I have AB line, H is equals to, let's say, 90, and I can change the color to green. And here you can see a green line at Y is equals to 90. If I know the slope and the intercept of a line, I can use that again using this AB line. This A and B are nothing but the intercept and the slope. So let's say intercept was 50, that is the y-intercept, and the slope was 0.3. If I press Control Enter, this is the line that we get. This black line is for the slope 0.3 and the y-intercept was 50. We can also create lines on an existing plot using the function lines. But for this, we need to know the x and the y coordinates of the points between which it will create lines. So let's say if I have these points, this was my first point, that is 65, 44. The next point is 62, 49. I guess this is the one, 62, 49. Then the next point is 50, 54. This is the third point. So similarly, if I want the lines to go through all of these points in this order, I can create this lines function. If I say lines in bracket, I'll give x comma y, both the coordinates. Then let's change the color. I'll give red line so that it is properly visible. And here you go. It is joining these points with lines. So if you have existing points, you can use the lines function to join them with lines. Again, to remind you, AB line and lines function will not work by themselves. It will work only if there is already a plot, and it will add lines to these plots. We have a similar function called points. This is used to add points to an existing plot. Let me clear these plots. Get the plot again, and I'll create new points on y-axis. I'll say y2 is equals to, because I'm going to use the same x-axis values, but I'm going to recreate y-axis values. I'll randomly write them. Let's say so I have now 10 points of this y2. I can create points. Again, points can only create points on an existing graph. So I will take the x and the y2 values and create those points on the scatter plot. I'll change the color so that we can see the difference. I'll say blue. So now you can see the blue points on this same scatter graph. These were created by these points function. You can again change the size of these points by CEX, let's say 4. And if I run this, I'll get, I forgot to put a comma here. So now I have the larger points here on the smaller points that were previously created. Now you can say that if I change this again, it will again create points on the existing points. If I have these as 10, I'll get very large points. So each time I'm using the points function, it is creating new points on the existing graph. Next, we are going to talk about curve. Curve is a function that is used to create a curve. So if I, let's say, have a function y is equals to some function of x, here I will take an example of quadratic function. So let's say 4 into x raised to 2 minus 3. And I want this curve from the value of minus 5 to 5 of x. These are nothing but the limits of x. If When I press Control Enter, I get a curve. You can always change the line type and line width using LTY and LWD. And you can always change the name by main, x-axis label, that would be xlab, and y-axis label by ylab. Everything works very similarly to what we have done before. A curve can be used to add a curve to the existing plot as well. So now let's say I will use the histogram that we have used before. So I have a data coming from a normal distribution and I am creating an histogram out of it. Here, if I want to make a curve of the density of a normal distribution to compare the data that came from the same normal distribution, I can use the curve function. I first give the expression of the density. So let's say denorm for the values of x and comma the mean and the standard deviation of normal distribution, that would be 25 and 36. Here I will not specify the values of x, but I will write add equal to true. This will tell the curve to add the curve to the existing plot. And let's say I will change the line type. I want LTY to be 2. I think that's the dashed line. And I want a width of the line to be 3. When I press Control Enter, here you can see that I have a black line, dashed line of width 3. So this way we can use the curve to add a curve to an existing plot. That's it for this video. In the next video, we are going to see how we can make the legends of any plot. Do like, share and subscribe, and I'll see you in the next one.